Hello everyone. Today we shall solve CSIR PYQ. So in this PYQ we have been asked what is the limsup and liminf of this sequence. So first of all, let us see what is limsup and liminf. So suppose AN is any sequence, okay? So we want to define what is limsup of AN. Obviously n tends to infinity. So first we shall consider the case in which AN is bounded above. Okay, so then we form a sequence Bn. We form a new sequence Bn. And what is the first element of the sequence Bn? Which is B1. B1 is nothing but supremum of A1, A2, and so on. And what is B2? B2 is supremum of A2, A3, and so on. Similarly, B3 would be supremum of A3, A4, A5. So in this way we form the sequence Bn. Okay. Now when we are done with the sequence Bn, then we define limsup of An to be the infimum of sequence Bn. Okay, so for example, suppose we have the sequence An which is like 3 minus 3 2 1 0 and then 1 0 1 0 1 0 and so on. Okay, so what is b1 here? B1 is supremum of all the sequence terms of an. So the supremum would be 3. Now b2 would be what? Supremum of, starting from this term, this is a1, a2, a3 and so on. So supremum of minus 3, 2, 1, 0 and so on. So here the supremum is 2, okay, in case of B2. And from B3, B3 would be supremum of 1, supremum of 2, 1, 0, 1 and so on. So it would be 2. And from B4 onwards, supremum would be what? Supremum 1, 0, 1, 0 and so on. So it would be 1. Again the B5 would also be 1, because after the B4 1 and 0 are coming alternatively, and then supremum would always be 1. So Bn is sequence and it is defined like 3 2 2 1 1 1 1 1. Okay, now limsup of An would be infimum of 3 2 2 1 1 and so on, means 1. Okay, so limsup An would be 1 in case of sequence we defined just above this sequence. Okay, but in actual practice we cannot always define, means we can define this like always, but it would be very long calculation and time taking thing. So if so there is one shortcut, not, there is actually a method. Suppose we have the sequence An, okay, which is bounded above, okay, and then suppose L is the limit point set of the sequence An. Okay, so An is what? Bounded above, and L is a set limit point set of the sequence. So the supremum of the set L would be limsup of an. Okay, this is the method we are going to use here. Okay, so similarly, uh, we can define lim infimum of an. That will be the infimum of the set L. Okay, but for limim to lim infimum, we should have the sequence an bounded below. Okay, and suppose suppose so for the sequence here, this sequence an, it is 1 plus minus 1 to the power n to the power n. This is actually, we should find first, we can see that it is a bounded sequence, no? Because see, terms are again, we can divide the sequence in terms of even and odd terms. So if n is odd number, so an would be 1 minus 1 by n to the power n, and if n is even, then it will be 1 plus 1 by n to the power n, something like that. Okay, so, and we know that if we form two complementary sequences like b2n and b2n minus 1, if they converge, suppose this converges to L1 and this converges to L2, then L1 and L2 would be limit point of the sequence an. Okay, and if L1 and L2 are equal, and then this sequence would be convergent sequence, and if they are not equal, then these 2 points will be the only limit points. Okay, so what is b2n? Okay, it is what, 1 plus 1 by 2n to the power 2n, and b2n minus 1 would be 1 minus 1 by 2n minus 1 to the power 2n minus 1. For the sake of convenience, assume 2n equals to what, m. So 1 plus 1 by m to the power m, and assume here 1 by uh, assume 2n minus 1 would to be what, p. Okay, so b2 bm is 1 plus 1 by m to the power n. Okay, so we can see that if we take limit m tends to infinity bm, it is what, it is of the form 1 to the power infinity. Now it is of the form this goes to 0 and then 1 to the power infinity. So how do we calculate the limit to sequence? So firstly form the alpha to be, so suppose if the sequence is like uh, 1 plus 1 by fx, hmm, and no, how do we solve this type of sequences? How do we solve? uh, there is a method, general method. Comment if you want to know, or I can solve here right now. Suppose any sequence which has a um, any sequence. Suppose suppose we want to find the limit of this sequence, no? So it is of the form 1 plus gx to the power fx, where as x tends to infinity, fx is going to infinity and gx is going to 0. So for this type of sequences, firstly calculate alpha. What is alpha? Alpha is limit n tends to infinity fx into 1 plus gx minus 1, and then L is what, e to the power alpha, whatever alpha comes here, and L is the limit of this sequence, 1 plus gx type sequence. So if we apply in that bm, Bm is what? 1 plus 1 by m to the power m. So alpha would be what? M. This m comes in front, m into 1 plus 1 by m minus 1. So alpha would be equals to 1. So L would be E. So in fact, Bm is a convergent sequence and it converges to E. Similarly, B P or B2n minus 1 is what? 1 plus, sorry, 1 minus 1 by 2n minus 1 to the power 2n minus 1. So again calculate alpha. Alpha is what? 2n minus 1 into 1 minus 1 by 2n minus 1 and minus 1. So minus 1 plus 1 minus 1 cancels out, and then alpha would be equals to limit 2n minus 1 into minus 1 upon 2n minus 1. So alpha is equals to minus 1, so L equals to E inverse, and we can see that B 2n minus 1 converges to 1 by E. So B2n and B2n minus 1 are complementary sequence, and this converges to E, this converges to 1 by E. So the limit point would be E and 1 by E. So limsup of an would be what? Supremum of this set, and lim at infimum would be infimum of E and 1 by E. This comes to be E, this comes to be 1 by E. So option fourth one is the correct answer. And in case the sequence an is not bounded above, not bounded above, so we won't go for the L limit set. We will take limsup to be plus infinity always. And if an is not bounded below, so we will take lim it infimum to be minus infinity. Okay, so that's all for today.